All right, let's get right into it. We're going to talk about something that is honestly one of the biggest, quietest risks in global health supply chains, the cold chain failure. It's a problem that happens behind the scenes, but its consequences are absolutely massive. I mean, just think about this for a second. We invest billions of dollars developing and making these incredible, life-saving medicines, but a huge chunk of them get ruined before they even get to a single patient. Not because there's a shortage, but simply because they got too warm or, and you'll see this as a big one, too cold. The stakes here are just incredibly high. So that's the million-dollar question, right? We have the technology. We know what needs to happen. So why do these critical supply lines keep breaking down? Well, that's exactly what we're going to unpack in this explainer. We're going to look at what the research says, and then what really, truly happens out in the field. To really get why things go wrong, we first have to understand what right is even supposed to look like. So let's quickly walk through the perfect high-stakes journey these medicines are supposed to take. The whole concept is called the cold chain, and it's pretty much what it sounds like, an unbroken chain of temperature-controlled environments. For most of these vaccines, we're talking about a very specific, very narrow window between 2 and 8 degrees Celsius. Not frozen, not even coolish. It has to be just right the entire time. And this journey, wow, it's a complicated one. It kicks off with international flights, then the medicines land in these large state-of-the-art central warehouses. From there, they're sent out to smaller regional stores. And finally, they have to survive the toughest part of all, that last-mile delivery out to the remote clinics where people are actually waiting for them. And this, right here, this is the heart of the challenge. You've heard the saying, a chain is only as strong as its weakest link. Well, that's literally true here. One single mistake, a box left on a hot airport tarmac for 30 minutes, a freezer that gets set just a degree too cold overnight, that's all it takes to ruin an entire batch. The control has to be constant. Okay, so with that perfect journey in mind, what happens when researchers and academics study this problem from, a 30,000-foot view? What does the data tell us? This is where it gets really, really interesting. The global research points to a few key things. First, this is not some rare freak accident. It's happening all the time. Second, and this surprises a lot of people, the biggest threat isn't the heat. It's actually accidental freezing. And third, get this, the problem usually isn't a lack of equipment. The temperature monitors, the data loggers, they're there. But the data often isn't looked at until after the medicines have been delivered. It's a classic case of too little, too late. Okay, so that's the high-level academic picture. Now let's get our boots on the ground and look at the messy reality. Where specifically does this perfect chain actually fall apart? Well, it almost never happens in those big, controlled warehouses. Look at this data. The vast majority of failures happen when the product is on the move, during road transport, at chaotic airports or loading docks, and during that critical final stretch. These are the moments where the product is most vulnerable. And why there? Because these are the moments where perfect plans and standard operating procedures collide with the real world. This is where a driver is rushing to meet a deadline, where a box sits on a loading dock for just a little too long, where the controlled bubble of the warehouse bursts. It's a perfect storm of environment, pressure, and human choice. And this shows you the dangerous disconnect. On paper, everything looks great. The shipment arrived, all the forms are signed, the boxes look fine. But what the paperwork doesn't show is that the little data logger inside tells a horrifying story. Those vaccines were frozen solid for hours on the truck. The damage is already done, and absolutely no one knows it. All of this brings us to the real, fundamental reason this problem is so hard to solve, and it's probably not what you're thinking. Here's the core idea. For years, we've approached this like a technical problem. We just need better refrigerators, or we need to write a longer procedure manual. But that's not it. This is fundamentally a governance issue. It's about how we manage systems, how we make decisions, and what we hold people accountable for. Just look at the difference here. The easy technical fix is to buy more stuff, more fridges, more loggers. But the real fix, the governance fix, is about changing the system itself. It's about having alarms that tell you there's a problem right now, not 2 days from now. It's about empowering that warehouse worker or that driver to say, stop, something is wrong here, without being afraid they'll be blamed. And it's about making it crystal clear who is responsible when things go wrong. Because when you don't have that strong governance, you end up creating a culture that, whether it means to or not, just accepts failure as a normal part of doing business. So why do people overlook these temperature alarms? Well, because humans are under enormous pressure. The big vaccination campaign starts tomorrow, so the deadline to just get the boxes there feels way more important than a small temperature spike. And when it's not clear who's actually accountable, it's just easier for everyone to sign the paper, pass the backs along, and hope for the best. The system accidentally rewards moving the shipment, not protecting the medicine. And that brings us to what might be the single most important sentence of this entire explainer. A temperature excursion ignored is a failure accepted. Every single time an alarm is dismissed or the data is checked too late, the system is making an unspoken choice to accept that failure. So we have to leave you with this question. The real challenge isn't technical. It's not about buying more hardware. It's about redesigning our systems and our cultures. How do we build a system that actually empowers people to see a risk and manage it, instead of a system that forces them to just accept it and move on? Answering that is the only way we're going to truly protect these incredible life-saving medicines.